We're going to look at a variety of problems, and we are going to be reviewing some of the information we've done already. So when we're looking at transformations here, this first one, it says state the transformation. So here's our function, the -1. So this part here moves it to the right one. Remember, minus is always the opposite, and then over here this is our vertical shift of up 3. The 2 and the negative, those are the tricky ones. So if you flip back in your notes a couple days, we have those reflections and stretches here. So let's see here. We have that 2, and the 2 is on the outside, so that's a vertical stretch with a factor of 2. So this one is vertical. And let's put our scale factor of 2. And then that negative, when the negative's on the outside, it's a reflect over the x-axis, because again we can think this whole thing is y, and we're taking the opposite of y, which would flip it down. So this is the x-axis reflection. And now we're asked to sketch a couple. So this first one, the 3x, if we go back again, 3's on the inside, and that's horizontal. It's affecting our x, so it's a horizontal, and it's a scale factor of 1/3. So if we take some of these points, and this will be a little bit more challenging, I might take, let's see, 1, 1. What's another nice one we have right here? What's this one? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So if we take 1/3 of those, well, 0, 0 stays the same. It would be 1/3, and 1/3 of this would go to 2. And so it was symmetric, so it has to go right here. So there's the 3x. Negative x, then we're taking the opposite of our x value. So the opposite of our x value, that's over the y, and since this is symmetric here, that's not going to change at all. So that one would stay the same because it just flips right over the y. And then up 1. Well, we can easily move these up 1. And there's our up 1 graph. We've also talked about inverses. And you guys remember inverse, we reverse our x and y. So this becomes x equals 3y minus 4. And well, this is a nice one to solve. Add 4. So we have x plus 4 equals 3y. Divide by 3. So we have x plus 4 over 3 equals our inverse there. Gets a little trickier when we have fractions, but we can start with that same process of reversing our x and y. X equals 4 over y minus 3. We can't have that y in the denominator, so we'll multiply each side by y minus 3. So now we have 4 over here. If we distribute, we have xy minus 3x. And our goal is to get those x's, the y on a side by itself. So we can add 3x. Xy equals 4 plus 3x. And we can then divide by x. So now our inverse is equal to 4 plus 3x over x. Now on a graph, we'll see if you guys remember what to do on a graph. This is where we can pick some xy coordinates. So let's see, we have 0 and -4. This one is 1, 2, 3, 4, 5. Maybe I'll put that one first. -5 and 0. 1 and 4, and 1, 2, 3, 4 and 4. So we can switch those. We have 0, -5, 0, 1, 2, 3, 4, 5, -4 and 0. Did I do that first? I just graphed that first one again. My bad. 0, -5 is down here. 1, 2, 3, 4, 5. Then we have -4 and 0, 1, 2, 3, 4, so it goes to -4, 0. Then it'll go to 1 and 4, so now it'll go to 4 and 1. 1, 2, 3, 4, and 1. And then it can go to, that other one is 4 and 4. So it would stay at 4 and 4. Now if you remember, if you're more of a visual person and want to double check this, we can say, well, yeah, it works. It's a reflection over that line, y equals x. So the other thing we're going to take a look at is evaluating some of these functions. So we need to evaluate f of negative 3. So we'll go to our f function. We know f of x equals x plus 1. So we can plug in negative 3, and we end up with negative 2. G of 4, well, our g function is x squared minus 3. So 4 squared minus 3, 16 minus 3 is 13. Then we have that composition. So we start with our outside, x squared minus 3.
Teachers and educators,
Circle
the
our
Weekly
x.
White Book Club will start in 5 minutes in the Learning Lab.
Sorry about that, guys. So we can replace our x with x plus 1 squared minus 3. And there is our composition. And what else are we going to take a look at? We're going to take a look at asymptotes. So if we pull up our calculator here and we graph that first one, let's see, what do we have? 2x over x plus 1. Alright, so looking at it here, well, it looks like negative 1 works. So x equals negative 1. And that fits because if we plug in negative 1 in the denominator, we get 0. And then our other one looks like it's at y equals 2. And then this bottom one, let's see, clear everything. And what do we have there? 3x minus 2 plus 4. Whoops, alright. So looking at this one, looks like maybe 2 and 1, 2, 3, 4. And we'll see if this one makes sense too. Well, x equals 2 definitely makes sense. 2 minus 2 is 0, and y equals 4. And that makes sense too because we've shifted it up 4. Interval notation. So we'll start with interval. X is greater than negative 3. So our smallest value is negative 3, and it can go on to infinity. This one, our smallest value is negative 1, but it includes it, so we use the square bracket up to 10. We'll have a parenthesis, and x is less than 5. So we have, suppose that needs to be interval notation, so it's less than, so it can be small, negative infinity to 5. And then that set notation, again, that's really similar to the inequalities we have here, except we have x such that x is greater than negative 3. And then we have x such that negative 1 is less than or equal to x is less than 10. And then we have x is less than 5. So x such that x is less than 5. Domain and range. I bet we can even do this one without graphing. So it's a parabola, and minus 3 moves it to the right 3. So our parabola looks like this. So our domain, we can plug in any x value, so our domain is all reals. But our y value there, it starts at the x-axis, so y has to be greater than or equal to 0. And if we were to graph this one, we'd find it would look like this, our square root function, but move to the left 4. So our domain, we don't have any x values until negative 4. So x has to be greater than or equal to negative 4. In our range, we don't have any negative y values, so y is greater than or equal to 0.